Well, one more thing. If you get a capacitor checker like this, which I highly recommend, guess what you have to do? You get to recap it too. So this has got a Heathkit Daystrom logo on it. Come on, camera. So that's a Heathkit Daystrom logo. So that dates this at least middle 60s, maybe a little later. It's an IT something or other. It's like it's an IT11. And so I had to put new capacitors in it. These Magic i2s get dim when they get old, and that's what's happened to this one. And I haven't put a new one in there. Nothing wrong with the tester. It's just the Magic i2s just get dim when they get old. You got to replace them. But they keep working even though they're dim. That's why I had the lights out during those videos so I could read the thing. But anyway, a very useful tool. This thing, this ESR tester, is no substitute for this. And this is basically just an ohm meter. That's all it is. It doesn't measure capacitance, doesn't do anything. It's just an expanded scale ohm meter. But this thing will give you a variety of tests, the most important of which is the leakage test and its ability to apply a stepwise voltage to it to reform capacitors, and showing you visually whether or not they're actually reforming. I think that's worth the price of admission. And then if you have an unknown capacitor, this thing will measure it and give you an approximate value. This could be calibrated better. I haven't done that because I don't need it, that function particularly, but within 20% the way it is right now, it's reasonably accurate, and I'm sure I could calibrate it without too much trouble. It might not be any harder than resetting the position of the pointer on the dial. But anyway, if you can get the manual for it, you can do all that fancy stuff. Okay, let's take a look at used capacitors, capacitor leakage, capacitor values, and electrolytic capacitor reforming. Right now, I've got this two-section electrolytic capacitor connected to this capacitor meter, and it's a 20 microfarad 450 two-section capacitor. So we're looking at one section of it, and right now I've got it in the leakage testing mode, and we've got 100 volts on it. And you can see that the meter is open here. Let me bump it up 50 volts and watch what happens. It closes down. If this capacitor was good, it would open up again very shortly. The capacitor would charge up a little more, and if the leakage was little or none, this thing would widen up like this. Well, here's the critical point, and it's 150 volts. Now this, when you try to reform a capacitor, you use a thing like this. This is one way to do it, and you move up the voltage scale stepwise. 50 volts at a time is a good way, and you let it sit there until it has reformed itself and the leakage goes to nothing. It looks like that. And then you go up the next bump. Well, this one has been sitting here at 150 volts for 20 minutes or a half hour, and it hasn't gotten any better. It will not reform. It will not quit leaking. Now, this isn't the worst leakage in the world. The worst leakage in the world, that thing would absolutely be closed. But this is not good and not getting any better. Now, I looked at some other capacitors in here, and the other tool you can use when you're looking at these used capacitors in a radio, and you're going to say, well, am I going to try to save them, or I'm just going to shotgun them? And of course, the safest thing to do is just get rid of this old shit and put in some new stuff. But if you want to try to see if what you have is usable, you haven't got any new capacitors, you can't afford any new capacitors, you're damn cheap to get any new capacitors, then you're going to have to test them. So the two tools are something like this, a leakage tester, where you can bump it up stepwise. If you can't do that, you can put a variac on it and use a voltmeter and wait for the thing to come up to voltage and then bump it up. The other thing is this thing. This is an ESR meter, which is electronic or electrical series resistance. Basically, it's an expanded range, low voltage ohm meter that only reads to 1 or 2 ohms at the most, but will give you, 0.01, a thousandth of an ohm kind of a reading. And you can use that in conjunction with this to characterize the health of a capacitor. Now, if you've got new capacitors, that certainly helps. And if you don't know what the readings mean, what you want to do is put a new capacitor on there of a similar value and voltage rating and see how it behaves. Now, if I put this new 22 microfarad 500 volt capacitor on here and run it up this voltage scale, it'll close down for a second, the capacitor will charge up, and this will open up, indicating no leakage. This thing just never gets any damn better. So now with these over here, I measured the ESR, the series resistance on them, and they were not too different from a new capacitor. And I said, well, that looks good. So then I put the leakage tester on there, and I started at 0 or 50 volts, and I worked my way up. And what I found was that like this one at about 100 volts, it closed down. But after a minute or so, it opened back up again, and I worked my way up the voltage scale until I was up to 450 volts. And as it reformed, each time I'd move up another step, until we got to the point where these things had reasonably low leakage. They had series resistance that wasn't significantly different from a new electrolytic, and I judged them to be usable. They have reformed, and I think that they'll work fine. Now those are the capacitors. These are replacements from the original, but these are the capacitors in the plate voltage supply. Now if I just slammed the full plate voltage on those things without reforming them, they would have destroyed themselves. They would have arced through, and that had been the end of them. But this one here is never going to reform. And when I measured the ESR on this, I had one section that was markedly higher than the other, and that's what we're looking at now. What I'm going to do here is go and measure the other section. That's the blue wire. Here's the red wire. This is the other section of it. I'll go down to 0, and we'll look at it together, and we'll see how this thing behaves. So I'm going to put it in the leakage mode. We're in the 0 voltage. It's hooked up. So there we go. It's wide open, no leakage. So we'll go up 50 volt steps. There's, what do we got here? I guess we got 10, 20 something. There's 50 volts. There's 100. Now that's what it should do. It should charge up and then open up to show no leakage. Let's go to 150 and see what it does. So now what we should see is a gradual opening of this eye as the capacitor reforms. So I don't know whether we're going to see that or not see that. We certainly didn't see it in the other section, and I got a feeling we won't see it here. Let's see. So I think that's going to be the same difference. It's academic anyway. Since one section of it is bad, we got to shit can the whole thing. But this is what happens when you get a bad capacitor, and certainly and this is critical here. In the low voltage section, this supplies the B plus for the high gain audio stages here. These are very susceptible to hum and ripple. Any hum and ripple in the power supply is going to be heard in your transmitted audio. You don't want that. So, and it also feeds the B plus to the VFO and the multiplier stages. So if there's any hum on there or ripple, that's going to be reflected in your transmitted signal, and you can hum modulate it through the VFO just as easily as you can through the modulator. So you don't want any second-rate capacitors in the low voltage section at all. So this definitely will be replaced with a couple of new jab caps here. These are 22 at 500 just because that's what I have, but that's very close to the right value of 20 microfarads. So 10%. These things aren't even, these things may be plus or 20 minus 20% from the factory. So the other thing you can do with a tool like this is measure the capacitance of the capacitors and see what their value is. This one is not terribly well calibrated. It's within about 20%, but it's not terribly well calibrated. Now these capacitors also came out of this radio. These are certainly not original. These were the filter caps from the bias supply, and they only had to be rated at 300 or 350 volts. These are 600. But these capacitors tested even lower in series, electrical series resistance than these new capacitors, and they showed excellent leakage as well. It's a little difficult with this device to measure their capacitance. I've got a solid state capacity meter that I could measure them with and get a more accurate reading. but chances are that these would work just fine as the filter caps in the bias supply. They're not original. They're physically way too big, and the voltage rating is much higher than they need to be, but that makes no difference. But these turned out to be quite good, and these I think are going to be acceptable. I think I may go ahead and use them. I'm going to bring it up on a variac anyway, so if there's any teething problems, the variac has a not only a voltmeter but a wattmeter, so I can see how much current the transmitter is drawing. So when I first fire it up, I'll bring it up on the variac. We've reformed the caps anyway with this thing, which is an excellent way to do it. Take them out of the circuit and bring them up 50 volts at a time until you can do this to discharge them, charge them up, and that thing should open right up again. That's what should happen with a good capacitor. So those are the two tools that are really best for doing this. If you're going to try to characterize a used cap, find out what its leakage is, find out what its effective series resistance is. Those two things are the great measure of leakage. The ESR thing, I think, is really kind of superfluous, because this thing really does an excellent job of showing you leakage and lets you test it at high voltage. This thing's only testing it at a couple of volts, and this thing you can go right up to 600 volts. So even though this is an old tool from the 60s, it happens to be an excellent tool. Now there's an even better tool. I've got one buried up here that's not working, but it's a Sprague telomic, which basically does the same thing as this, but with a more sophisticated and accurate circuit. But it will give you a capacitance bridge where you can measure capacitance. It'll measure leakage, all those good things. And of course all these things check for shorts and open capacitors as well. But anyhow, there we go. Just to beat a dead horse, the right way to do this is shotgun all these electrolytic and paper caps. Don't fool with the old crap. Cut them out, put them in a can, and put in new stuff, and never worry about the thing failing when you use it. Never worry about a capacitor failing and wiping out an expensive transformer or embarrassing you on the air. Just put in the new caps. But if you have to, for some reason, and you want to try to reform caps, so you believe you've got something that has new enough electrolytics that, or they've got a history of being good, like Heathkit PS23s and SP200 amplifiers. Those electrolytics tend to last forever. So if you think you have something where the caps can be reformed, these are the tools and the process you need. But in something as old as this 1950s Valiant, I really suggest that you shotgun everything in. Receivers, you really just want to put new caps in. Leave the micas alone. Get rid of the paper caps and the electrolytics. These things, these paper caps, you have to change those things. You have to.